Hi all, I'm T. Shaktishri, Assistant Professor of Department of Information Technology in Hindustan College of Engineering and Technology. In this video, we are going to learn about the searching algorithm. Let us see what a searching is and the different types of searching algorithms available, which are linear search and binary search. Getting into the term of search. Searching means finding a particular element. A search algorithm can be termed as a method of locating a specific item of information in a longer collection of data. This searching can be done in two ways, linear search and then binary search. First, let us see what a linear search algorithm is. This is a very simple algorithm, and in linear search, we are going to start comparing the elements, the element to be found from the first element. The search will be proceeded until we reach the element to be found. So, programmatically, we will be making use of a loop to sequentially step through an array starting with the first element. It compares each element with the value being searched for and stops when the value is found or we reach the end of the array. Now let us see how the linear search has been proceeded with the help of an example. The common examples of a linear search can be termed as, if you are making a search in a name list, we will be starting from the first person to the end. We will be searching our name from the first name till we get our name, right? So we'll be starting with the first element and we'll be proceeding with the next element until we found our name, or will be, if the name is not found, we'll be proceeding a search till the end of the list. That is a common example of a linear search. In linear search, we don't have any preconditions at all. So given a list, you'll be, and given an element to be found, you'll be able to go with the linear search. In this example, we have been provided with 9 elements and that has been stored in an array starting from the index position 0 to 8. Out of this, the element to be searched is given as 41. Let us see how this has been proceeded. So now let us see how the element 41 has been searched in linear search algorithm. The search starts with the first element. Here in our given list of elements, the first element is 70, which will be compared with the key element, which is 41. As it is not equal, we will be proceeding a search to the next element. The next element is 40. Again, this 40 is not equivalent to the key element to be found. If the element is not the key element to be found, then again move on with the next elements. Like this, we will be continuing with the next element. During the 5th or 6th search, we will be able to get our key element, which is being located in the array of size at the array position 5. So now we have found the element. As we have found the element, we can terminate the algorithm. This is one way. The another way is that maybe the key element which has to be found may not be present in the array. At that case, the searching will be proceeded from the first till the last element. After that, it has to produce a message like the element not found. Now let us see the analysis of linear search. The best case time complexity of linear search is order of 1, which means that there is a possibility that the element to be found may be present in the first position. The worst case complexity is the element to be found may be at the last position, so it is going to be order of n, and average case complexity is going to be order of n, because in all other cases it can be at any other position. So in general it can be represented as order of n. So this is the routine for linear search. So here we are going to get the size of the array followed by the input elements for the array, and then we are going to get the element to be searched, and through the for loop we are going to search the key element to be found starting from the position 0 till the last element. We will be comparing the key element with the array content. If it is found, we will be marking it as 1 and then will be coming out of the entire looping. Otherwise, will be terming like the element to be found is not there or it is not present in the array. The next type of searching is binary search. The binary search is much more efficient than the linear search. But the only condition what it requires is the element to be searched should be in ascending or descending order. This algorithm, binary search, is based on divide and conquer strategy, where it works by looking at the middle element of the array. If the value it holds is lower than the search element, then eliminate the first half of the array from further consideration. If the value it holds is higher than the search element, then eliminate the second half of the array from further consideration. Repeat this process until the element is found or until the entire array has been searched. The best example of binary search is dictionary search. In dictionary search, we will not be searching the meaning for a particular word from the first page onwards. For example, if we want to find a meaning for a word which starts from B, we will be directly moving on to the page which contains the letter P. Almost half of the list will not be searched over there. Wherever we have these type of searching, all those things can be termed as an example of a binary search. Let us take, for example, we have been provided with 9 array content and the element to be searched here is 44. To proceed with the binary search, we have to make use of 3 main things. One is low value, high value and then mid value. Low value is going to be the lowest index and high value is the highest index, and middle will be calculated by making use of the formula low plus high divided by 2. As this is the first search, our low value is 0 and high value is 8, and middle value is going to be 0 plus 8 divided by 2, which is going to be 4 over here. That is, it points to the array index value. So what has to be done here is that the key element here, which is going to be 44, will be searched with the middle element. The middle element here is 38 and the element to be found is 44, which is larger than the middle element. So if it is larger than the middle element, then the lower half of the array will be left and we'll be proceeding a search only on the other half of the array. Let us see how that is going to happen in the next slide. As I already mentioned, we are going to proceed our search only on the next, that is a lower part will be discarded and we are going to get into the higher part. So now the middle element, that is the key element is going to be 44 and we are going to proceed the search only in the half of the array. So here the low is going to be 5 and middle value will be calculated based upon the value of low and high. So the high remains the same over here. So 5 plus 8 divided by 2, which is going to be 13 divided by 2, will be getting the value to be 6.5. So we'll be taking the middle value to be 6 over here, right? So we have fixed the low, middle and high values over here, and the key element to be searched is 44. As the key element to be searched is 44, it will be compared with the middle element. When comparing the key element with the middle element, the element to be found is lesser than the middle element. If it is lesser, then we are going to proceed a search only in the lower half and we are going to discard the next half of the array. So getting into the third pass, we just have one element which has been left out here. This is a special case and almost in every cases we'll be getting some situations like this. So here the low is 5, high is also 5, and when we calculate the middle value, it is also going to be 5. And we have to compare the key element, which is 44, with the middle element over here. So the key element 44 is compared with the middle element. As it matches, we have successfully searched the given key element. Getting to the analysis of binary search. The worst case complexity is going to be order of n. It is because the element to be found may require so many number of searches to be found over there. The best case and average case time complexity is going to be order of log n. It is because we are going to proceed our search only in one half of the entire array, either on the left hand side or on the right hand side. So almost half of the array content has been skipped over there. So we term the time complexity of both the best case and average case time complexity to be log n. So this is the routine of binary search. Binary search can be proceeded either in a sequential manner or in a recursive approach. So this is an example of a sequential approach where we have got the length of the array followed by the array content. The array content has to be in ascending order. That is one of the main restrictions that we have to follow when we go for the binary search. The next is the element to be searched. We have to mark the beginning to be 0, end to be n minus 1 and middle to be beginning plus n divided by 2. we have to compare our item with the middle element. If it is equal, then the element to be found has been searched and that we have reached the successful search over here. If not, if the middle element is lesser than the item, or if the item is greater than the middle element, then we have to proceed a search in the upper half. So when we do the search on the upper half, there won't be any change in the end element. The only change will be happening in the beginning. So beginning will be marked as mid plus 1 as we are skipping the lower half. If it is not, which means that if the item to be searched is less than the middle element, then the searching will be proceeded in the lower half. When we proceed a search in the lower half, the begin remains the same, which is 0, and the end will be marked as middle minus 1. It is because we are going to skip the upper half over here, right? So like this it will be proceeding, and at the end, if the location is equal to mid, then it means that we have found the particular element over here. So in recursive approach, instead of making use of for loop as like in the previous example, previous routine, here we make use of a recursive approach. The same thing where we'll be calculating the values like end, start and then middle, everything will be calculated. If the array content, the middle element and the key element to be found is equal, then we'll be returning the middle element. If not, if the key element is lesser than the middle element, then we are going to proceed a search in the left half. For that, we have to make a call to the same function binary search with the change. Start remains the same, but there will be a change in middle minus 1. That is, the higher element will be changed as middle minus 1. If it is not, there will be a change in the first position. That is, the start will be made as middle plus 1 and the end remains the same. Right? So like this, we are going to make a call to the binary search to the lower half and the upper half. So this is a recursive approach. Recursive approach is more efficient than the normal linear approach. I hope in this video you might have got a better understanding about what a searching algorithm is and what are the different type of searchings available and the exact demonstration of linear search and binary search with an example. Thank you.